Okay, welcome. This is data collection for investigation 8. We're going to do another titration, but this one's a redox titration. And the redox reaction is between potassium permanganate and hydrogen peroxide. So usually we put the thing we're analyzing down here. This would be the analyte, and then we put our titrant up here. We're going to basically standardize store-bought hydrogen peroxide. We want to figure out what percentage of hydrogen peroxide there is inside this solution. And so hydrogen peroxide would be our analyte, and then potassium permanganate would be our titrant. This we already know the molarity of because I made it. The molarity of potassium permanganate is going to be 0.0202 molar. So again, the concentration of potassium permanganate is 0.0202 molar. And we know that because I made it. I weighed out the solid, I diluted it up to the line, which is 100 milliliters, and then I calculated out the molarity. So typically, our sodium hydroxide would go down here because that's our analyte. But for the sake of the burette, we're going to flip it for a couple of different reasons. Again, we're trying to save our burette and make it work for generations to come. And potassium permanganate, A, has solid dissolved in it. So if not all the solid is dissolved perfectly, that solid is going to get lodged right here and screw with my dispensing mechanism. The second thing is we're going to acidify our potassium permanganate. We're going to put some sulfuric acid in with our potassium permanganate so that it forms the products we want it to form. And I don't want super concentrated sulfuric acid going through my plastic and on my burette because eventually that's going to degrade it and ruin it. So I'm going to flip them. I'm going to put the potassium permanganate down here in the bottom, which is my titrant because I know the concentration of that solution going in. And then I'm going to put my hydrogen peroxide, which is my analyte, into my burette. Okay, so now that we have that established, let's go ahead and prep everything. You can see I have my magnet here, my stir bar here. I have it on my stir plate. I'm going to rinse my burette because the last thing I had in here was not hydrogen peroxide. Okay, now that that's rinsed, I'm going to put some brand new hydrogen peroxide in there. Now, hydrogen peroxide tends to self-decompose. It reacts with itself and falls apart into water and oxygen gas. So I'm going to use a brand new jar of hydrogen peroxide so that we make sure it is as close to being new from the factory as possible. All right, and then I want to make sure I get my reading. That is at 10.95. Okay. 10.95 milliliters is going to be my initial burette reading of the peroxide. Okay, and now we need to measure out some potassium permanganate. So I have about 100 milliliters here. I'm going to measure out about 30 milliliters for my rough titration. Okay, so one thing to note about potassium permanganate is it's very purple. Do you guys see that? See that purple color? That is really a telltale sign of potassium permanganate. And the AP College Board loves to test to see whether you've actually dealt with potassium permanganate or not by asking you what the color changes in this experiment are. So knowing that potassium permanganate is purple is very helpful. Also, we need a starting volume here. We're going to say 28.5 milliliters of KMnO4. And then we need to add some sulfuric acid. You can also use that sulfuric acid to try to wash a little bit of the potassium permanganate in as well. When dealing with really strong acid, you always want to add acid to water. Because it's a pretty strong reaction between the two. As you just saw, it like fizzled and smoked. So we want to make sure that there's plenty of water there to absorb that energy that gets released when acid mixes with water, dissolves in the water. Okay, here we go. So we're going to start our stir bar. I also want to say that the only reason I'm sitting down doing a lot of these when I talk to you is because I need to be in the camera when I'm talking to you. Normally in lab, you don't want to sit down ever because anything that spills is going to run right into your lap. If you're weighing solids, you're going to dump the extra solid into your lap. If something tips over or goes wrong with the burette, it all goes into your lap, and you definitely don't want these chemicals in your lap. So technique tip for lab, don't sit down. Okay, we're gonna do our rough titration here to try and figure out how much per hydrogen peroxide it's gonna take to acidify the solution. And pay attention to color changes. So I've already gotten a color change there, but we're gonna go until the color change is complete so that we know that all of our potassium permanganate has reacted. Ooh, actually, I wanted that to be our rough titration, but I got one drop to change that color for me. So we may just go with this measurement. Okay, we are currently at 12.10. So not very much volume of peroxide. Let's repeat that experiment and see if we can get an average. Okay, one thing on disposal of this is you have super strong potassium or sodium, acid, which is sulfuric acid. You have pretty strong sulfuric acid in here, so you don't want to just dump this down the drain. That acid needs to be neutralized before it actually goes into the drain. So we're going to put this into the dump bucket. And then rinse everything and start over. Okay, this volume is 33.5. So second trial, volume of potassium permanganate, 33.5 milliliters. Some acid there. Here, I'll put this out front so you can kind of see the pop and fizzle when I add the acid to the solution of potassium permanganate. our stir bar back. Okay, here we go again. So notice as the reaction's proceeding forward, it's turning to a much lighter color, and at the end of the last one, hopefully you saw that it went clear. You'll be able to see that again. Ooh, and I probably overshot that one a little bit so we can compare the amount needed for that reaction, but I think I overshot that one a little bit. So 13.75 is the peroxide reading off the burette, 13.75 milliliters. Let's run it one more time. Oh shoot, I need to measure that. All right, hold on. All right, 42.5. 42.5 milliliters of potassium permanganate. Add a little acid. Rinse our permanganate a little bit. All right, let's go. Getting lighter in color. I'm going to move you closer so you can see this color change one more time. Let's see if I can go drop by drop. Still getting lighter. Oh. You see flashes of clear. One more drop maybe. Yep, there we go. And it's clear. So one source of error you might notice are all of these little potassium permanganate drops up here. That would definitely be sources of error and throw off my calculation in the end. Let's see what our ending burette reading is. Let's see, can you make that reading? Let me give you a background. What would you say that reading is? Remember, burettes are read upside down. So it's not 17 something, it's 16 something. I'll put you down and I'll make the reading. So 16.40. 16.40 would be your reading on that one. And I'm going to put stars by the first trial and the second trial, and I'm going to put a note by the, first and third I'm going to put stars by. I'll put a note by the second trial and just say like overshot, question mark, and then I can compare my results on those three and see if the first and the third really are closer. Okay, just time for cleanup.